Hey, welcome to video 11-2. This is Explain 1 on page 588, and in this video we're going to be determining how we can figure out from the coordinates or the diagram whether two figures are similar or not. So we're going to represent the dilation using the coordinate notation as you see here. xy becomes kx times ky. That's really important that k is the scale factor on both x and y coordinates so that we're kind of distorting each one equally, if you will. And then the center of dilation is the origin. If you have a 0 to 1 k factor, the dilation is a reduction, which means it's going to get smaller. And if our k value is bigger than 1, then we're going to expect our pre-image to image to actually get larger. So on part A here, we're looking to determine whether RST is able to dilate onto XYZ from looking at the coordinates. So if we look at the coordinates of 0, 1, 1, -1, and -1, -1, which are the pre-image points here in this first column. Oops, sorry, I keep doing that. The pre-images in this first column. And then we compare it to the image points of XYZ, which become, instead of 0, 1, 0, 3, instead of 1, 1, 3, -3, and then instead of -1, -1, -3, 3. The discussion continues on the next page here. You can clearly see that each of those coordinates on the pre-image is multiplied by 3, so we have a 3x times 3y coordinate notation, and therefore the dilation is a similarity transformation. Now again, that was true because the 3 was the multiplier for every single point. So in part B here, we're going to expect that if we go from little rectangle here, PQRS, to rectangle WXYZ, then we would expect that scale factor to be the same throughout. So let's first of all go ahead and fill in the values here that are missing. We have point R, which is the point 64. We have point S, which is the point 62. We have the point W, which is 5, 5. And we have the point Y, which is 12, 9. So we're going to find each distance. We're going to find that from P to Q, and we're just counting this right along the grid here, is 2. And then Q to R, over here, across horizontally, is 4. WX, we can say, is 4. And XY, if we go ahead and count across the top of that top rectangle, XY is actually 7. So if we can take and multiply a number, K, times the length of PQ, and get its corresponding side over here, WX, then we can assume that we have a K is 2 for this first one. And you can see that that's not a problem there. However, we cannot multiply WX by 2 and get XY. 4 times 2 is not 7. So because no value of K is going to determine that, we can say that the figures are not, since they're not equal, that they are not similar. Another way to think about that, and this is just kind of a little side note, as I'm looking at the multiplier between, again, the pre-image and the image, I might go ahead and take a k value for this first point between from P to W would be to multiply everything by 2.5 to go from 2 to 5. But then if I were to multiply the 0.24 by a scale factor of 2.5, I would get a 5, but this 9 here would actually supposed to be 10 if it were going to follow that scale factor of 2.5, and so since it's 9 instead of 10, then I can say right there that it is not a dilation. It's not going to be similar in that way. Alright, so at the end of this video here, you're just going to go ahead and work on the your turns at the bottom of this page 589, and again you're going to be considering whether the two figures are similar using a similarity transformation, and that's again comparing their coordinates. And so if I were you, I would go ahead and make sure that you know from the beginning here, just like you did above, make a column of pre-image points and a column of image points to fill in, and that'll make your analysis a little easier for L, M, N, O, and so on. So pause the video here and make sure that you check your answer to the Your Turn when you are finished on the online document. And we'll see you guys in the morning.